And now we're on to cones. So our last section we looked at cylinders, which it's a 3D solid that has two bases, both circles, congruent circles, right? And the distance connecting them is the height. A cone is one base, circle, like a cylinder, and then it stretches up to a point. So we're going to call the distance from the center of the base, the center of the circle, to this point here, that is the height. And as you can see from the drawing here, that the height is perpendicular to that circular base. This here is called the slant height. Slant height is used in surface area calculations, which we're not doing, but just wanted to tell you the name for it, and also that in some of the volume calculations we need to use the slant height to, for example, find the radius or the height. So if you recall, also with cylinders, cross-section is when you take a flat surface and chop through a 3D solid object. So, for example, starting with a cone, if I slice through it parallel to the base, so I have a cone, do you see how if I slice parallel through it and hit right here, see how I have like another little cone on top? Take that top cone, throw it away, and now look down at the top of this new shape, and you will see that that top is a circle. Okay, so if you remember, just like in cylinders, if you have a cross section that's parallel to the base, your cross section is the shape of the base. Now, if I cut perpendicular to the base, so if I cut down, slice through the middle of the cone from top to bottom like this, look at this outlined shape. You get a triangle as a cross section. So that's saying if I slice through the top of the cone and throw this half of it away, and now look at the side, I'll see a triangle. And just like what would happen with the cylinder, if I cut diagonally through the cone, I get that kind of stretched out looking circle, kind of like an oval, which we call an ellipse. These are cross sections. It's when a flat plane, a 2D flat surface, slices through the 3D object. Where does that plane hit the object? What shape is that? That's the cross section. Okay? So, if you recall, the formula for cylinder was that the volume of the cylinder is pi r squared times h. That's the area of the base times the height. Cone is actually obviously going to be different because it's a different object. It's 1/3 times the area of the base times the height. So what that means is if you have a cone and a cylinder with the same circle base and the same height, that if you fill up 3 cones, it will, let's say, fill up the cone 3 times with liquid and dump it into the cylinder, that would equal the cylinder's full volume. Okay? So just like what we did with cylinder, the base of a cone is always a circle. So instead of saying 1/3 times the area of the base times the height every time, for a cone we just say 1/3 times pi times r squared times h, because pi r squared is the area of the circle. So this is what we're using for our volume of a cone formula. So here we go. Just like we do with cylinders, sometimes they ask us for the exact answer, and sometimes they ask us for the rounded answer. If you look at the cone, it got knocked on its side, but it doesn't affect our calculations. This 7 here is the radius, and the 24 is the height. It's the distance from the center of the circular base to this point here. So I write these down. R is 7 meters, h is 24 meters, and then I have my formula right here, 1/3 pi r squared h. I substitute those values in, and then we just need to simplify. So I'm going to square this first, 49. Then I multiplied by 24 and got 1176. Then I multiply by a third or divide by 3, same thing. I get 392, and I put the pi in the side. Remember, that's 392 times pi. But when it says exact volume in terms of pi, you want to leave the pi in the answer. So that's why I multiplied all the other numbers and left the pi. So my exact volume is 392 pi meters cubed because it's volume, so the units are always cubed. Okay. Now, if I asked you to round that, you would just type 392 times pi in your calculator and round to 2 decimal places because they want nearest hundredth, and that's what I got. Up here, Example 2 is nearly the same, except in this one, if you notice, they gave me the entire length of the diameter of the circle. From here to here is 4, so I go diameter is 4 feet, so the radius is 2 feet. Then I plugged in that 2 for r squared, and here I go. Now they wanted me to get exact, so I didn't want to round, so I left it as a fraction. 44 pi divided by 3. But when they say, do you want to round that here, I just go, okay, 44 times pi, enter, divide 3, enter, and I round to 2 decimal places, and I end up right. You can go ahead and try the next couple examples if you want, and then check back here. Now, example 3 is pretty straightforward. Again, 8 is the diameter, so the radius is 4, and then the height is 7. So I'm going to plug in 1/3 times pi times 4 squared times 7, and this is what I get. Now, notice how example 3 did not ask for the exact answer. So I just go 1/12 pi, enter, divide 3, enter, and I get this answer right here. And since the measurements were in yards, the volume is in yards cubed. Over here, it gets a little bit strange, but the reason why I wrote it like that is because, again, I want to be as precise as possible, as accurate as possible. So I don't want to keep rounding a bunch of times. So that's why I wrote the work in that format. So let's see. The diameter is 24.7, so divided that by 2 to get the radius. That's 12.35. Okay. Now, they gave me the radius, 12.35, and then they gave me the slant height, but they did not give me the height. And I need the height to find the volume. But if you notice, the height is always perpendicular to the base. That's why we put in this right angle here. So it's a right triangle in there. So I'm going to do the Pythagorean theorem. So I did h squared plus 12.35 squared equals like squared plus like squared equals hypotenuse squared. 26 hypotenuse. Notice that I did not use 24.7 because that's the entire length of the diameter. I needed half of that, which is the radius. So I square, square. Subtracted this long decimal here. So 8 squared equals this decimal. And then how do I go from 8 squared to 8 squared? Again, we're only keeping the positive answer because you can't have a negative length. So the height is the square root of that big number. Now, I could have approximated that, but I didn't because I only want to round once at the end. So I'm going to show you how I would do that. So the radius is right here, 12.35. The height is this big number. And then this is what I have to do to get the answer. I have to do 1/3 times pi times radius squared times this number. I will show you what this looks like in the calculator. So this question doesn't ask for the exact answer at all. It just says for the rounded answer, which is good for us. So we can turn all of this into a decimal. So first I'm going to start with the square root because that's the most stuff to type in. So I type in the square root of that decimal and I hit enter. And now that's saved in there and I'm not going to round. I'm just going to keep typing in the other things I have. So I also have to multiply it by 12.35 squared. So you notice how I use the parentheses. Then I also have to multiply it by pi. So the only other thing I haven't done yet in entering this in the calculator is multiplying by 1/3. Multiplying by 1/3 is the same as dividing by 3. But when I hit divide now, notice how it says answer divided by 3. It's taking all the other stuff I multiplied together, and it's going to do that. That's ANS, that's the answer, divided by 3. And so that's the answer that I got. And I round to this decimal place, so this stays as 6 because this is only a 1. So that's where I got this answer here. So go ahead and try the next example on your own. Keep in mind though that it's half of a cone, so the volume of that solid should be half of what you would get if it was the full size of a cone. So try it. You can pause it. Okay. Did you get this answer? Notice this is the slant height, is 25, okay? The diameter of what would be the circle, only a semicircle, is 14, so that means the radius is 7. So if you look here, this triangle right here is a right triangle. So we're going to do the Pythagorean theorem. So I did height squared plus 7 squared equals 25 squared. 25 is the hypotenuse of this triangle. And I got the height is 24. So the radius is 7, the height is 24. And then remember, our normal volume formula for a cone is 1/3 times pi times r squared times h. So that would be right here, 1/3 times pi times r squared times h. Except that solid right there is half of a cone. It got cut in half. See the cross section? So I did a times 1/2. I need half of the formula for the cone. Instead of multiplying by half, you could have also done the whole thing by 2. It's the same thing. So I do 1/2 times 1/3 is 1/6. So instead of normally doing 1/3 times all this, I'm just going to do 1/6 times the remainder. Well, how do I get these numbers? I do 7 squared, that's 49. Then I do 49 times 24, that's 1176. And I have times pi. And so when I'm right here, I can just do 1176 divided by 6. That gives me 196. The exact answer is 196 pi. It's units cubed because it's volume. If I want to round it to the nearest hundredth, I just do 196 times pi. And I'll get this answer. Our last one here is a preview. We're going to do more of these towards the end of the chapter. This is called composite solids. Look at the picture. You can see that it's a cylinder with a cone on top of it. We want to fill up the entire volume. So the volume is if I fill the entire thing up with liquid. Okay, how much do I need? Well, I need to do the cylinder formula, and then I need to do the cone formula. I need to add them up. So I have the volume of a cylinder here, volume of a cone. You can look up the formula. The cylinder formula is pi times r squared times h, and the cone formula is 1/3 pi r squared h. Now, if you look at the cylinder, do you see how 1 is the radius of that circle? But look at the bottom part of the cylinder and the bottom part of the cone. These are the same, these are congruent circles. So the radius of the cylinder is 1, the radius of the cone is 1. Now, the height of from here to here, this whole height is 13. But the height of the cone, as you can see right here, is 2. So that means that the height of the cylinder is 13 minus 2, which is 11. Okay? So I do, what's the volume of the cylinder? Pi times 1 squared times 11. Pi times r squared times height. That's 11 pi. What's the volume of the cone? 1/3 times pi times 1 squared times 2. So it's 2/3 pi. So here's the volume of the cylinder. Here's the volume of the cone. What's the total volume? I add them up. Now, what I wanted to do is to be the most accurate is as you can see right here, I just added up the 11 pi plus the 2/3 pi and then rounded at the end. So that's composite solid. So cylinder, pi r squared times h will give you the volume of the cylinder. Cone, 1/3 times pi times r squared times h will give you the volume of the cone. In this case, we had to do both to get the total volume of the composite solid.